In today's video, we are going to explore the fascinating journey behind the history of the atom, how various scientists across centuries contributed to building our understanding of atomic structure through theories and experiments that forever changed science. It all began with a concept known as atomic theory, which was first proposed by an ancient Greek philosopher named Democritus, who lived around 500 years before Christ. He suggested that all matter is made up of extremely tiny, indivisible particles called atoms, and these particles are separated by empty space. However, for nearly 2,000 years, no significant advancements were made until the early 1800s, when John Dalton revisited and expanded upon this idea. Dalton described atoms as solid, indivisible spheres, and more importantly, proposed that different elements are made up of different types of atoms, essentially different types of solid spheres. Then came a revolutionary shift in the late 19th century. In the year 1897, J. Thomson conducted a series of experiments involving cathode rays, which led to the discovery of negatively charged particles now known as electrons. These findings disproved Dalton's solid sphere model, and in response, Thomson introduced what became known as the Plum Pudding Model. According to this model, the atom was thought to be a sphere of positive charge with negatively charged electrons embedded randomly within it, somewhat like raisins in a pudding. However, this too was challenged just over a decade later. In 1909, Ernest Rutherford and his students performed the famous gold foil experiment. They bombarded a thin sheet of gold foil with positively charged alpha particles, expecting them to pass straight through if Thomson's model were accurate. Surprisingly though, while most alpha particles did pass through, some were deflected at sharp angles, and a few even bounced straight back. This unexpected result proved that the positive charge in an atom was not spread out but rather concentrated in a small, dense region. As a result, Rutherford proposed the nuclear model of the atom, which stated that all positive charge and most of the mass was located in a tiny central nucleus, and that the negatively charged electrons were scattered in a cloud surrounding this nucleus. While this model was a major breakthrough, it had a critical flaw. It could not explain why the negatively charged electrons didn't just spiral into the positively charged nucleus and collapse the atom. This problem was addressed 4 years later, in 1913, by the Danish physicist Niels Bohr. Bohr suggested that electrons orbit the nucleus in fixed energy levels or shells, similar to how planets orbit the Sun, and that these shells prevented the electrons from losing energy and collapsing into the nucleus. This planetary model of the atom helped resolve the instability issue and laid the foundation for modern atomic theory. Since then, many experiments have supported Bohr's model with only slight refinements. Later research by Rutherford himself revealed that the nucleus contains even smaller positive particles called protons, and in 1932, James Chadwick discovered the presence of neutral particles in the nucleus, which we now call neutrons. Together, protons and neutrons form the atomic nucleus, and electrons orbit this nucleus in shells, a structure that remains the basis of our current understanding of the atom. And that's how centuries of inquiry and experimentation led to the atomic model we use today. Anyway, that's all for this video. We hope it helped clarify the evolution of atomic theory, and if you found it useful, please like, comment, and subscribe. See you next time.